Okay, Martin is a PhD researcher at Imperial, working for the Ministry of Defense, working with electroencephalogram technologies for improving attention in people who are on duty and very much need to pay attention.
Oliver is a PhD student at Cardiff University. He's a binary vision programmer. He's looking at earthworms.
But also brain hacking. And together we are focusing on a small startup effort to try and get some cognitive stimulation products into the marketplace. We'll move on with the talk.
I'll tell you about it. So we'll give you a little motivation first, why we're interested in this, why it's important. Then a little background, what some things mean, what we're measuring, what we'll be talking about. Then neurostimulation, how can you change the brain? How can you, improve your cognition, improve your performance? Then we'll tell you about DIY electronics, how to build some of these things, and at the end, why it's important to combine them.
So we are going to move quite quickly through a lot of stuff. We're going to have to give you some background quite quickly so that we can explain what we're really on about. But the real overarching purpose of this talk, as I said, is to raise awareness, to demonstrate what the future may hold in the commercial marketplace for these kinds of products. We'll get on to looking at some gear that exists presently that we have with us towards the end, hopefully. And one of our friends is apparently turning up with some more gear, so fingers crossed for that.
Yeah, well, maybe we get to see plenty of stuff.
So let us advance.
All right, so why brain hacking? Well, we're hackers, programmers. We like building and understanding complex things and fun things, and the brain is about as complex and fun as it gets. At the same time, it's hacking because a lot of the things are still quite crude. We don't know how everything affects your brain. We don't understand everything about the brain. But at the same time, why would we do this then? Well, we do understand some things. We do know what some of the stimulation protocols do, as we'll tell you about them. We do know what some of the signals mean. We know when you're paying attention, for example, right now, or when you're sleepy. We can tell quite a few things. Quite importantly, I do believe it's kind of the golden era of neurotechnology over the next few years. You see lots of startups, and I think lots of more people will be getting into this thing. The technology and interest is very high right now. So also, if you're interested, get into it. It's great stuff. And last but not least, we are transhumanists. We believe in constantly striving to improve ourselves with technology and furthering our understanding of ourselves and our environment. And the brain is as direct a way as it gets to do that. All right, so just very briefly, for those of you that might not know, the brain has this outer part, which is the most recently evolved part of the neocortex, and that looks like that. When you think of the brain, you're thinking of the neocortex typically, and the outermost part has gray matter, and inside you have white matter. It's like the connections between different parts of the brain, and the green matter has neurons, neuronal cell bodies. They generate signals, so voltage fluctuations. And we can measure this. We can measure this with electrodes, which I'll tell you about a little bit later after the neurostimulation part. That's quite important.
Well, most importantly, we can change the voltages.
That's right. And we'll talk about that. So, just briefly, what about neurostimulation? Well, we'll be telling about TDCS, TACS, TMS. TDCS is transcranial direct current stimulation. TACS is transcranial alternating current stimulation. And TMS is transcranial magnetic stimulation. TMS is where essentially you have a coil of wire or electrically conductive material, and you pass a current quickly through it, and what happens is that generates a quickly changing magnetic field. And a quickly changing magnetic field, as Faraday's law says, as some of you might know, induces a current in electrically conductive materials. So that's
such as a neuron.
Such as a neuron, such as your brain in your brain. And so we can cause neurons to fire. We can cause them to be silenced. The issue with TMS is it's very bulky, it's very expensive, huge machinery. Though we are working on fixing that someone. This is what TMS currently looks like. It's you have these huge butterfly coils, which I'll tell you more about in a bit. It's very powerful magnetic fields. They alter your brain. very effective actually. If you see, if you go on YouTube and you look at a video of this, you can see people like twitching from quite impressive things.
Not in a seizure way, you know.
Right.
Control switch.
All right. In TDCS, we have direct current, so you can think of this a little bit as taking a battery and taking the positive end and the negative end, sticking it to two or more parts of your brain, and you run a current. And you can, the positive part is known as the anode, negative part is known as the cathode. And under the anode in your brain, you are increasing neuronal activity. Under the cathode, you decrease neuronal activity, so you silence neurons. And this is quite a well-established and researched way of altering brain activity today. It's you can think of the brain in your head as kind of a variable resistor, so the resistance changes all the time. And as long as you're taking that into account, you can control the current that goes into your brain. And Oliver will tell you more about that. And so last we have transcranial AC stimulation. You just have alternating current instead of direct current. The point here is that with TACS, you have a lot more possibilities for your stimulation. You can change the frequency, you can change the phase, you can change the amplitude. So it's more elaborate. It's a little bit more complicated. You can do more things. And it's also being researched heavily now. With TDCS, we have lots of things have been done. People have improved various people have improved brains after injury, but also in healthy people, short-term memory has been improved, arithmetic, abstract reasoning, all sorts of things. So this is something you can do today, and we'll tell you about how to build your own kit. It's very easy to do, very safe actually. Believe it or not. So yeah, mention that. Also, while TDCS kind of the way we'll tell you about it, kind of just doing it straight up, it's not very specific. You can't target very specific areas of the brain. There are ways to do that, but we won't tell you too much about it. If you use MRI and you have kind of high-resolution brain scans, then you can model where the current goes, and you can do some magic. But we won't be telling too much about that. This is just to illustrate the cingulate gyrus is deep in the brain. We can actually stimulate it quite accurately and precisely if you have brain images from an MRI first. But all right, so now okay, give it over.
So, I think I'll move here. So the real question, what I'm going to talk about first is, before moving on to the DIY side, is why you need to DIY. And that is because you can't really buy very much at the moment that's going to give you some positive results. Mostly at the moment, if you want to experience cognitive enhancement through electrical means, it's going to be down to your own research, learning, and we're going to be covering some of that. So first of all, we're going to do sort of a little bit of a thought experiment about what products could exist with the technology that we currently have, the research that has been done, and sort of why they don't. Yes. So yes, at the moment there's a lot of research going on. So it's produced for researchers in very low quantities, and it's often incredibly expensive despite being relatively simple, because they have to charge huge amounts to recoup the amount that they've spent on design and man hours in the development process. So it can, and I said 1,000 plus, it can be tens of thousands of pounds for actually relatively simple components. Other options you have are, there is one roughly £50 option if you're looking to be a bit of an amateur hacker. And perhaps I would recommend this if you don't want to actually get into the electronics yourself. I'll look at it in a moment. There's also quite an interesting product called the Focus TDCS device, which was targeted towards gamers. And I'm not quite sure how well it's taken off, because perhaps because of the price tag, I feel as though this is something that could have been quite a lot lower, considering the simplicity of the core of it. I mean, it's quite nice product, just lots bundled around the essential stimulation protocol. But still, we shall move on. And of course, there is medical grade equipment too, as cognitive stimulation is also a clinical thing, but this is not our prototype at the moment. So yes, a Californian company recently came out with this, which is a very handy bit of gear, just providing a constant current source if you want to stimulate your brain using electrodes. It can kind of build upon itself, but yes, be moderate thing. Okay, so fun stuff. We're on to sort of building your own. Yeah, there's going to be a couple of formulas in here, but again, nothing more complicated than a tax return, probably simpler. So what do you need to actually build your own TDCS device? Well, if you want to be a true brain hacker, then you need to have a constant current source. You need to have a way to push that current through the 10 to 20 k ohms resistance, roughly, of the human skull and brain. And some electrodes, which are in fact incredibly cheap. So let's just have a quick look at like an extreme bare bones circuit, like it's like nothing, right? So all you really need is some batteries and a constant current source device component. This is the LM334. I know it's been used a lot in amateur TDCS projects, and it's quite reliable. So I would probably recommend using something like this. It's just a way of controlling the current across the brain, because obviously your brain's resistance can change. So you just need to be able to guarantee a constant current source. And to do that, very simply, I've taken the formula from the tech sheet, from the specification sheet. All you need to do is basically plug in the resistance, the amperage value that you want to achieve. So for simplicity, if we want to achieve a 1 milliamp stimulation, we would have a resistance of sort of 67 ohms, and that would give us, and so that's incredibly simple. There's like only several components that make up the kind of the core of the circuit that you would need to use. And so as a power source, in order to get the energy actually through the brain, you refer to Ohm's law to just make sure you have the highest, you have a voltage that is capable of overcoming resistance at that amperage level. And 18 volts should push a reasonable dosage through even the thickest of skulls. Okay, so it's also possible to do things like substitute the resistor for a potentiometer, and then you can create a variable current source, variable current quantity based on what you want. And yes, plug the values into the formula again to find the potentiometer for you. And finally, yes, you will need some electrodes. Now, just a quick word about electrodes is I've noticed some people, these are actually TNS electrodes which are used for muscular stimulation, but they're so abundantly available and cheap that you might as well use them. What I do is they have a water-resistant adhesive on them, and that can kind of irritate the scalp a little bit because it's generally designed to like use on the body. What I think is awesome to do is you can cut off a really thin layer of sponge, just put that on top of the electrode, and then when you wet it to achieve contact with the skull, then it won't come off because the adhesive is water resistant, so it's great. And then, yeah, so I just kind of snip off the little connectors and solder away, basically. And yes, just return to the circuit diagram. So, here's one of you notice I like to wear headbands, right? So I think it's perfect for stimulating the prefrontal cortex. So as you can see, I've turned it into a little spongy thing here. I can put in my head. I'm not going to be stimulated right now because I'm not wet. But so yeah, and this took me a couple of hours one afternoon to make. It's really the components are just housed in here. I've got a 9-volt battery on either side. It's really quite easy to make. I got a single pole double throw, I think. Basically, I also added a little bit where I can change the directional flow of the current, so like switch the anode or cathode. But you know, that's just, again some very simple messing around. Yes, so hopefully that has enthused you about what you can just go out there and do to yourself. And yeah, so now we've talked about some of the simpler, let's say crude, simple, cheap, effective ways we can make products. But there's also another side of the coin. Moving into the future, we recognize those creates scope optimization as well. And that's something that comes from personalization of the stimulation protocol, and that comes from recognizing what's going on inside the individual brain. And in order to do that, we'll take you over to the expert.
Thank you. So to do that, we need to record brain activity. So we do that with electrodes. Again, we're looking at activity from the gray matter. And when we say electrodes, for those of you that might not know, we're just saying really pieces of metal that record the electrical activity. Typically,
it's slightly different to the electrodes that I was talking to before.
Yeah, those are basically sponges.
Yeah, they have the same name
for whatever reason. So usually we're looking at silver chloride. They're very cheap, and it's really one of the best and easiest way to record directly neuroactivity. It might look something like this in research with 128 electrodes. You can actually go up to 256 even. Might look like this. This is a Russian MITSAR EEG system used for neurofeedback. This is the star stim, which we have here. We'll show you this afterwards if you want to see it. This can record and stimulate, so it can do TDCS, TACS, TRNS, and do EEG. It's pretty cool. Then we have the emotive epoch, which we have somewhere here, which I can show you if you want it afterwards. It's 14 electrodes, white electrodes. Just putting it on.
Now we have
then you have one electrode, dry electrode, and the mind wave. Some of you may have seen this already. It's quite cheap. It's $100. Just very, very briefly, it's quite important. I mean, if you want to modify the brain, you should also understand it a little bit. So what the EEG measures is postsynaptic potentials from superficial radial layers of the cortex. What that means is, if you look here, it's the horizontal patches of this outer part of the brain. And that's what really EEG is measuring. So it doesn't measure everything. It doesn't really measure the vertical parts very well. Those are measured by something called MEG, or magnetoencephalography. That's not DIY friendly. You need superconducting magnetic sensors. So we're not going to talk about that. But the point is, interpretation of what you're measuring with EEG is not that simple. It's a mixture of complicated things, but we can tell a few things. We can tell, we can tell which stage of sleep you're in, your level of arousal. Have you slept recently? Have you not slept so well recently? So we can tell quite a few things. This is a nice picture. This is a nice picture of intracranial EEG, or electrocorticography, ECOG. So this is where we're hopefully taking things with all of us. Hopefully we'll build them.
Any volunteers?
So I mean, this is great because it allows you to record with much higher specificity, much better signal-to-noise ratios. It's great. But maybe not everyone's up for it. So when we record EEG data, as we'll hopefully show you afterwards, it looks something like this. If you plot it, you have these names at the side. These are just positions from the 1020 system. So you can just kind of see which electrode is, the different activities. Then you can analyze this with kind of time analysis, frequency analysis, time frequency analysis, but also machine learning and statistical methods for those of you that are interested in that. Yes, it's important to extract meaningful things from EEG because then we can do something for a specific brain state. So as we'll tell you in the next slide, the trick is really combining what Audra was talking about, neurostimulation, with neurorecording, EEG. Then we can do things for your brain state at a specific time. So let's go to the next slide. Oh, not yet. Okay, before we get to that, so you have research in medical EEG, just like with neurostimulation. They're very expensive, but there's also cheap ones. You've seen the Epoch, is it on? There's a Mindwave, there's Open BCI, which is really cool. It's coming out, I think you can pre-order it now online. So if you're interested in this, check it out, it's great. It's $400 to $700. Just briefly, there's dry electrodes and wet electrodes. The EPOG that Oliver is wearing is wet electrodes, so you need to put some gel. It's not very, it's not very nice. You have to put this gel, and it's messy. But we're moving more and more to dry electrodes. This is Emotive's Insight coming out sometime next year, beginning of next year. You just put it on and it works, just like the MindWave. This is something that's currently being developed at Imperial. This is what I'm using in my PhD research, working with. It's in-ear EEG, so you just put it in. It's wireless, dry electrodes. You just put it in, and it measures your brain waves, your attentional level, and then you can play sounds. You can put current through the brain, through the device, and improve yourself.
Yeah. So when we bring these two things together, what we have is the products of the future, hopefully. When there is a marketplace that is big enough to substantiate a sort of a higher tier product at a consumer level, what we've done with the kind of £50, £20 entry level things, then what we are looking to get towards in terms of our company is we are combining particularly TMS stimulation with miniaturization ideas with electroencephalography to really target the parts of the brain that need to be targeted. In the sense, you can create a personalized stimulation profile for yourself when you need it for a given activity. Because we can record how your brain behaves during a given activity, we can infer from that how it best be stimulated, or maybe suboptimal way, but at least a way that works for you. Particularly because not all brains are completely typical. If you had a slightly cruder option, while it may be fun and good for most people, there's a chance that it wouldn't always work for any given individual, and in any case, there's huge scope for optimization. So this is kind of where we are going and what we'd like to see really happening in the future. If you're like a sort of serious professional who is looking to really increase their skill level in anything.